Whenever you're trying to solve a quadratic equation, and of course by quadratic equation we mean something of the form ax squared plus bx plus c equal to 0, where a, b, and c are all elements of the real numbers, as well as a not being equal to 0. Whenever you try and solve an equation of this form, there are several techniques you can try and use. You could try to factor. But factoring doesn't always work. You can try completing the square. Completing the square will always give you your solution or solutions, but it can be a little bit complicated. There's a formula, though, that you can use, and regardless of how many answers you're going to get, what kind of numbers those answers are, this formula will always work. That formula is x equal to opposite of b. And don't read this as negative b. If b is positive, sure, it'll show up negative down here. But if b starts out negative, this will make it positive. So read this as opposite of b plus and minus the square root of b squared minus 4 times a times c. And this is all over 2 times a. And this is your quadratic formula. This formula will solve any quadratic that you need to solve, regardless of how many answers it has and what kind of numbers those answers are. This formula will do it. So let's just jump straight in and take a look at a few examples. Let's look at x squared plus 11x plus 10 equal to 0. Whenever you're using the quadratic formula, I suggest you first of all have it right in front of you so you can just insert values into it just by looking at it and not from memory. And you also need to make a list of your a, your b, and your c value. In this example, a equals 1 because you assume it's a 1x squared, b equals 11, and c equals 10. So now we put it in the formula. The solution to this equation is x equal to opposite of b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. Now, and this is a good thing to punch into your calculator. But before you try and put it all in all at once, I suggest that you just use the calculator to first evaluate your discriminant. Now, the discriminant is the part or the portion of the formula that you find underneath the square root. And you need to put it into your calculator exactly the way you see it written here. So we'll go to the calculator and we'll put in the 11 squared minus the 4 times the 1 times the 10. Again, typing it in exactly the way you saw it. And this tells us we have a discriminant of 81. So we'll go back to the formula. So x will equal to a negative 11 plus and minus the square root of 81 over 2 times 1, which is 2. Now notice that the 81 is a perfect square, which means I can go ahead and take this square root. Square root of 81 is 9. And since that 81 was a perfect square, I was able to take its square root, and I will now be able to do this addition. Negative 11 plus 9 is a negative 2. Negative 2 over 2 is one answer. Negative 11 minus 9 is a negative 20. When I reduce these two fractions, there I have my two answers. Now it shouldn't be too much of a surprise that these two answers turn out to be nice rational numbers. The reason we knew that this was going to happen was again because of the 81. Anytime the discriminant is a perfect square, you're going to get two rational answers. So let's make note of that. B squared minus 4AC, if it equals a perfect square, that implies two rational answers. Okay, so let's move on to another example. Let's clear this away. We'll do it on this same page because we already have our formula written down here where we can easily look at it and plug in. So let's just stay with this page. Let's take a look at x squared plus a 9x plus 18 equal to 0. Again, labeling everything. A is 1, B is 9, and C is 18. We go and we plug into the formula. Opposite of B would be a negative 9. Plus and minus, square root of the 9 squared minus a 4 times the A times the C, and it's again all over 2 times A. Again, let's evaluate just the discriminant. It's going to be a 9 squared minus 4 times 1 times the 18. This discriminant is a 9. What does this tell us? Well, once again, we know because of this discriminant being a perfect square, we're going to get two rational answers for this problem. So it's going to be a negative 9 plus and minus 3 over 2. Negative 9 plus 3 is a negative 6 over 2. Negative 9 minus 3 is a negative 12 over 2, which is a negative 3 and a negative 6. Again, two rational answers. Now let's see if we can find an example of where we not only have different coefficients, but perhaps a problem where we don't have nice, perfect, rational answers coming out. So let's again clear this away. And look for our next example. Let's say we had a 2x squared plus a 6x equaling 5. First thing we notice is this is written in a very bad order, meaning the 5 is on the wrong side. So I would immediately move the 5 over, so we have an x squared term first, x next, constant last, always equal to 0. Now we know that our a is 2, our b is 6, and our c is a negative 5. Plugging into our formula, get that x equal to the opposite of b plus n minus square root of the b squared minus the 4 times the a times the c all over 2 times a. Next is the discriminant. Say 6 squared minus 4 times the 2 times the negative 5. This discriminant turns out to be a 76. So I'm going to have x equaling negative 6 plus and minus the square root of 76 over 4. Now that discriminant was not a perfect square, but it's still positive. Since it's equal to a positive number, and square root of a positive number is irrational, that means we're going to have two irrational solutions or answers. Okay, so we'll break this apart. This is a negative 6 plus n minus the square root of 76 breaks down into a 4 times 19 all over 4, which is negative 6 plus and minus 2 square roots of 19 over 4. Now since all three of these values can be divided by 2, I can reduce, and I have my two irrational solutions. Okay? Now, our next example is going to be a situation in which, let's just go to the next page for this one. We don't have two rational solutions. We don't have two irrational solutions. Something different is going to happen. Let's say we had a x squared plus actually, I think I want to change things a little bit. Let's make it minus a 6x equaling negative 9. Like before, got to bring the 9 over so everything's set equal to 0. My a equals 1. My b equals negative 6. My c equals 9. Remember, your formula is x equal to opposite of b plus n minus square root of b squared minus 4ac all over 2a. So I start plugging in x equal to, now since b is a negative 6, opposite of b will show up as a positive 6 plus n minus the square root of the negative 6 squared minus 4 times the 1 times the 9 all over 2 times 1. Again, going for the discriminant. Alright, in our discriminant we're going to have the negative 6 squared minus 4 times 1 times 9, so parentheses are necessary. Negative 6 squared minus the 4 times the 1 times the 9, and we find our discriminant to be 0. So this gives us 6 plus or minus the square root of 0 over 2, which is just 6 over 2, since the square root of 0 is 0. So what we've found is that when the discriminant equals 0, we have one rational solution. Now, as far as the discriminant is concerned, there's one more possibility. There's one more thing that can happen with the discriminant, and this is something we definitely need to look into. Let's take a 3x squared equaling an x minus 1. Again, this is arranged in a very poor order, so I need to rewrite this as 3x squared minus x plus 1 equals 0, just moving things to the other side. My a equals 3, my b equals negative 1, my c equals positive 1. Quadratic is written down, so I can start plugging in. X will be equal to the opposite of b plus n minus the square root of the b squared minus 4 times the a times the c all over 2 times a. And let's go figure the discriminant. Clear the calculator screen, and remember, it's a 1 squared minus 4 times 3 times 1. So negative 1 squared minus the 4 times the 3 times the 1. And we find the discriminant to be a negative 11. So we get the x equals 1 plus n minus the square root of negative 11 over 6. Now, as you know, we cannot take the square root of a negative number. So what this implies for us is that this problem has no real, and by real we mean real number, solution. So we can come back here again and summarize. If the b squared minus 4ac equals a negative value, then that implies no real solution. Now, as far as the quadratic formula is concerned, if you can simply memorize it and plug things in correctly, it will solve for you any type of quadratic that you wish to solve, plus the discriminant will tell you what type of solutions you should be expecting once you get to the end of the formula.